Hello, fellow ag nerd. Thank you so much for joining me for this episode of the Future of Agriculture podcast. My name is Tim Hamrich, and if you believe that ag innovation is a solution to some of our world's most important problems, you have found the right show, and I'm sure glad you're here. Thanks so much to everyone who has filled out the audience survey so far. Those responses have been a massive help to me. And if you haven't yet, please just take a minute and let us know what you think of this show. It really is helpful, and I'm putting the feedback I'm getting from this directly into work on the future of this show, so I do highly appreciate it. The link for that is in the show notes if you haven't already filled it out. If you have ever tried to grow any food crop, even just a garden, you know that insect pests are unavoidable. Over the past 100 years or so, chemical pesticides have been developed as efficient and cost-effective ways for farmers to manage these pests. But as I'm sure you know, they're not without their downsides. Pests are building resistance. They are constantly under environmental and safety scrutiny. And frankly, there hasn't been much innovation in this space in a very long time. Our guests on the show today, Rath and Ben Cicora, are of the company Vestaron. They say, we've seen this before. They'll lay out a case for you that what's happening right now in ag chem has already played out in human pharmaceuticals. The clear winner, they say, has been biotechnology, namely using peptides, which are essentially just proteins, only smaller, instead of chemistry. In human pharmaceuticals, this gave rise to companies like Genentech and Amgen. In agriculture, Vestaron is pioneering these peptide-based products that claim to have the same effectiveness as the chemical alternatives, but with a new mode of action and without some of the negative externalities of chemicals. Now, I want to be really clear here because it can get confusing. Peptides are different from what we consider in agriculture biologicals. You may hear about biostimulants or biopesticides, all part of biologicals, this category that has sort of all been lumped together over time. Those are generally microbes. These are, as I said, short-chain amino acids, basically proteins, only smaller. So they're not ag chemicals, but they're also not ag biologicals in the classic definition of that term. Making this point clear is a bit of a challenge and part of what they're facing in their commercialization efforts, and we're going to get into that in the episode here. So I know some of this sounds a little bit technical, but I highly recommend you stick around and give this episode a listen. If this is the first time you're hearing about peptides, I guarantee you it won't be the last time. But before we dive into things with Anna and Ben, I want to tell you about another podcast I'm also hosting called SWAT Agronomy. This show is produced by Croptomistic Technology, the makers of SWAT maps. You might remember Croptomistic President Corey Wilness from when he was on this show last year back in episode 211. The SWAT Agronomy Podcast features people who stand at the cutting edge of where technology meets agronomy. We're just 4 episodes in so far, but we've already shared some cool stories about farmers and agronomists putting technology to work in their operations. So if you're interested in on-farm application of precision ag technology, you definitely want to subscribe to that podcast. It's called, again, SWAT Agronomy. You can find it on any podcast platform. Okay, back to today's episode with Rath and Ben Cicora from Vestaron. Anna has a master's degree in genetics and a law degree from Yale. And after spending some time in consulting, she spent 14 years working for ag tech startups, first working in commercial development, then founding and growing a company of her own. In 2018, Vestaron recruited her to be CEO of what was then a 15-person R&D team. And since that time, she's been tasked with commercializing the products and finalizing regulatory approval. Soon after she joined Vestaron, she brought Ben aboard as Senior VP of Sales and Marketing. Ben has an MBA from UNC Chapel Hill and has spent most of his career in ag chem, including 9 years with Dow AgroSciences, 5 years with Bayer, and right before Vestaron, he was a part of a U.S. commercialization effort for a small Canadian fertility company. So we're going to dive into the details here about the impact of this technology on the future of agriculture. But for starters, Anna lays out in a really compelling way what's happening in ag chem today and how it parallels what has already happened in human pharmaceuticals.
I just fell in love with the technology and the revolutionary potential that it has because it's exactly the same technology that revolutionized pharma 40 years ago. And it's so clear to me that ag chems is hitting the same wall that pharma hit 40 years ago. And there's no reason why the solution that worked there isn't exactly the same solution that should work here. And so that just felt to me like something that I could explain, create a vision around, and really help to develop.
Let's stick right there on that point, though. What is that wall that pharma hit upon and now that ag chem is running up against? And why is this peptide technology part of the answer, if not the answer?
Yeah, so 40 years ago, pharma was all small molecule discovery and development, all done in-house in a handful of majors. And small molecules are really good at doing what they're supposed to do. They bind to their target in a reliable manner, and they have a reliable effect when they do that. The problem is small molecules are also promiscuous. So they also bind to things that they are not supposed to bind to. And when they do that, it leads to all sorts of negative side effects. In pharma, that's negative human health consequences. In ag, that's things like harm to beneficial insects, right? Or harm to the environment, or harm to, field labor. And so what happened when pharma hit this wall was, first, a bunch of blockbusters started to be pulled from the market, then increasing regulatory scrutiny, then increasing product development costs and timelines. As a result, dearth of innovation. As a result, huge wave of M&A, and then rise of the biologics. Where are we today in ag chems, right? Blockbusters being pulled from the market. As a result, increasing regulatory scrutiny. As a result, increasing product development costs and timelines. As a result, dearth of innovation. We've just seen our huge wave of M&A, and what comes next? We would argue rise of the biologics. When pharma says biologics, though, they mean a very different thing than what ag traditionally means. So in pharma, biologics equals proteins. And that's for two very important reasons. The first reason is that proteins can bind to their target every bit as reliably as small molecules and have that same kind of known, reliable interaction, drug to target interaction that gets you the reliable efficacy that you want, right, from a pesticide or from a drug. But bigger molecule, bigger binding site, so much more specific to that intended target. So proteins, peptides are just small proteins, peptides or proteins are much less likely to bind to things that they are not supposed to bind to and have negative side effects as a result. So that's one really key feature of proteins and by extension peptides. The other key feature is that sometimes it wasn't the original small molecule that had those negative side effects. It was some metabolite of that small molecule, something that your body or the body of any organism or the environment would turn that small molecule into. Proteins, when they get into your body or into the environment, they just degrade to amino acids. So in the environment, as we degrade, we're just a nitrogen source. And so for those two reasons, when pharma hit the wall and needed to evolve, it evolved to proteins. And now 7 of the 9 largest selling pharmaceuticals on the market are biologics, are proteins. And we see no reason why that same kind of transformation doesn't happen in ag chems.
Very interesting. What does that wall look like exactly when it comes to what happened with pharma and now what you say is happening with big ag? I mean, we have seen consolidation. We have seen big technologies be pulled from the market due to regulation. Have we already hit that wall, or what's sort of the final straw that says like, oh no, now we've hit the wall? How do you see that playing out?
I would tell you it's the fact that there hasn't been a novel nerve and muscular mode of action granted by the IRAC code to any of the rest of the industry other than Vestaron since 2007 and Rynaxypyr. So 14 years without a novel, highly effective chemistry for growers to include in their rotation, that seems like pretty much a wall to me. There are only ever in the whole history of insecticidal chemistry 14 nerve and muscular modes of action, right? They collectively account for 85% of the global insecticidal chemistry market, right? Those are the effective ways to kill a bug. Turns out those 14 nerve and muscular modes of action only actually address 8 different receptors in an insect, because you can bind to the same receptor at multiple different locations. 6 of those receptors are the most important. So 6 receptors in an insect account for 80% of the global insecticidal chemistry market, right? And so what are we doing? We are basically redrugging, if you will, those proven insecticidal receptors, the ones that have given rise to billion-dollar products on the synthetic side, we're simply binding to that same receptor at a different location. So it's a novel mode of action, so it won't have cross-resistance. And we're doing that with safe, environmentally friendly molecules.
So you think we've already hit the wall, in a sense?
Oh, of course, right? I mean, if you look at the publicly available information on pipelines, it looks like the next novel mode of action, novel nerve and muscular mode of action coming out of any of the majors is going to be sort of mid-decade, right? Which means they're going to have gone from 2007 to mid-decade, sort of 18 years, 17, 18 years between, useful, right, highly effective nerve and muscular modes of action. Vestaron, we received our first for spear in 2018. We expect to receive our second one this year, our third one next year, our fourth one the year after. So 4 novel nerve and muscular modes of action in 6 years, when the whole rest of the industry is taking 18 years between them. That's a wall, and this is the solution.
And one more question for you that I want to put Ben on the hot seat a little bit here, but what we call biologicals are different than what pharma calls them. So why have they seemed to, I don't know that I want to say catch on, but why have they seemed to catch on and peptides haven't up to this point?
Yep, peptides had some big challenges in agriculture. So people have been working on peptides for agriculture for decades. Just nobody before Vestaron was able to make it work. And so what were those challenges? Well, the 2 biggest ones are you have to be able to manufacture them at agricultural costs of goods, right? Which are very different from pharma, where whatever your cost is, you can get it reimbursed. And so that was a big hurdle that Vestaron had to overcome, was being able to manufacture these things at scale and at yield levels that would get us to competitive cost of goods where we can price, as we do, at parity with the leading synthetics. So that was major challenge number 1. Major challenge number 2 is these are bigger molecules. And so in pharma, when you're dealing with a big molecule, you can get it into the bloodstream by giving somebody a shot, right? Can't do that so much with insects in the field. And so we needed to figure out how we were going to get that big molecule from the mouth of the insect, right, when it eats the leaf and picks up the pesticide, into the effectively bloodstream, right, the hemolymph of the insect where the target receptor resides. And so what we have figured out to do is to pair our peptide with a very small sublethal dose of a gut disruptor, something that would poke holes in the gut of the insect, and therefore create the path that our peptides can use to get from the mouth of the insect out into the bloodstream and thereby the target receptor. And so the first major gut disruptor that we have paired with is a BT. And so we pair with a BTK to kill lepidopteran pests. We can pair with BTT to kill coleopteran pests, and so on and so forth.
But it's not the BT that's actually harming the insect. It's actually the peptide.
Nope. And you can tell that in 2 ways. One is that we can use very, very sublethal doses of BT and still have full control of the pests. The other way you can tell that is the reason that BT hasn't ever been a bigger product on its own is that it is not super UV stable. And so it doesn't have long run field efficacy. And so typically not long enough to get you full control over an insect population. We've shown field efficacy in, controlled third-party studies out to 30 days in the field. No BT has ever done that. No biologic has ever done that.
Okay. And Ben, talk to us about Spear T, right? Spear T is the kind of the first product. How's that rolling out as far as what pests are you targeting? What crops? What's the impact of this technology that's now been on the market for a few years now, right?
Actually, 2020 was our first commercial year in the marketplace. We have 2 products in the market. There's Spear T and Spear Lep. And Spear T is basically our contact product for soft body insects, so thrips, mites, aphids, whiteflies, spotted wing Drosophila. It's purely a contact kill. We get bioavailability to what Anna was talking about earlier through the spiracles, the breathing apparatus on those pests. Spear Lep is what we pair with a low dose of BTK to get extended residual lepidopteran control in the marketplace. And that's through oral ingestion. So again, we use that sublethal dose of BTK to puncture holes in the midgut, allow the peptide to flood through into the hemolymph, and then you get that residual control in line with a lot of the synthetic standards in the marketplace.
And from a farmer standpoint, Are they looking at this as, hey, this is just like synthetic, but it probably is more likely to be around longer due to resistance and modes of action, that sort of thing? Or are there other benefits, that go along with them as well?
So a lot of the feedback that we're getting is, they look at these as a direct replacement of their current synthetic IPM program or in conjunction with that. So one of the things that Anna was referring to is kind of redrugging those proven targets of insecticidal chemistries. What we can do now is also extend the life of a lot of the products that are having resistance challenges in the marketplace. So in a case where a grower may have diamondback moth resistance to their diamides that they're using, now they can rotate our new novel modes of action into that rotation and potentially extend the life of that diamide even further out into the future. So we give a lot of optionality in how we can plug and play into current IPM programs with growers.
Well, I was just going to say on the subject of other benefits of our products, they do offer really all of the same kinds of safety and environmental benefits that you get from the biologics. And so that is 0-day pre-harvest, which can be huge for making your operations work. It is 4-hour reentry, which is again great for operations and great for worker safety. It is the exemption from MRLs. It's great that we are, pollinator friendly and to have all of those, soft attributes. But a lot of the benefit of those soft attributes are actually hard operational advantages for growers.
It does look like you all have, at least just looking at some of the materials that are out there, focused mostly on specialty crops, at least initially. Is that true?
Yeah, our initial introductions, are really focused on those high value permanent crops or high value vegetable fruit crops, mostly because our production system isn't fully operational yet. So when you look at volume and opportunity, that's kind of the, no pun intended, but low hanging fruit that we can come into the market. And they're the ones that are having a lot of the challenges with the resistant issues. We do see ourselves bridging in the near future into some of the row crop segments, where they're also having a lot of challenges. So when you look at a lot of the non-GMO planted corn or soybeans that are having insecticide challenges, when you look at soybeans in the Mid-South with the soybean looper resistance that's beginning to develop to the BT traded soybeans, as well as cotton with bollworm resistance. So we do see ourselves bridging into that fairly soon. For us, it's just a matter of introduction, building that scale, and being able to introduce in those segments.
And I was just thinking, going back to the last point and Ben mentioning that one of the really nice things about those sort of favorable attributes of Spear is the ability for the grower to carry their sustainability message down the chain. I think it's an interesting point that it's also coming from the end of the chain backwards. And so we increasingly interact with branded food companies, right, who are very concerned about their own sustainability message and who do things like dictate what their growers can and can't use. And those companies are all quite concerned because what they've seen is that list of allowable chemistries has just been shrinking and shrinking and shrinking, right, with nothing coming in to bring that list back to what it once was. And so we have programs going with a number of companies of that sort who are very excited about getting it to a place where they could have an integrated pest management program that is based entirely on the kinds of products that have the favorable attributes that peptides do.
Yeah, that kind of brings me to something I wanted to ask you about, which is sometimes the best solutions are the hardest to understand on the surface. So, do we have a bit of a customer education challenge here in that, wait, is this a biological that's just as effective as synthetic, or is it a synthetic that has the benefits of a biological? And where do we put this? And if I'm General Mills, how do I tell my uneducated public when it comes to how their food's produced that this is good?
Yeah, that is the challenge we face every day. It is truly an education, both of the grower all the way through the channel and to the food companies, right? And this is very new technology on the surface. It's easy for people to kind of lump it into the biological bucket, but we are very much not a biological in the traditional sense of the word in agriculture. And I think once we sit down and have a chance in front of an audience and be able to explain how we work, how we target those specific receptors, why we're so different than a traditional biological that most of their modes of action aren't even known in a lot of cases, it becomes more evident to them that we are more of a synthetic biological at that point. And that's kind of a new bucket that we fit in. And I think for us, specifically when we start talking about sustainability messages, I think what we're really trying to show is the revolution that we're bringing in kind of the environmental science side of ag chemicals and how we can evolve into working with a lot of the natural systems that are in place that growers are trying to use, whether it be with pheromones or beneficials. We can really displace some small molecules fairly easy in those type of platforms. When you start talking to a lot of the food companies, their understanding is organic isn't really sustainable for the long term. And being able to farm in a truly more sustainable manner is probably more realistic in the long term. So when you start to look at, things that are going on out in the market with Blue Diamond almonds or Kind Bar focused on bee-friendly almonds only going forward, I think by 2025, those are the folks that we really want to target and help educate that our solution really is a strong fit for them for the long term and being able to maintain those beneficial populations and basically deliver the commodity they need in a more suitable, sustainable manner.
And to make sure we're really clear on that point, the aspect of these peptides that make them very, very specific as opposed to general, as we talked about earlier with some of the, synthetic chemistry that's been used in the past, is what gives you the confidence of saying this isn't going to hurt pollinators, right?
Right. Yeah. Because of the avenue that they go through. So, BTs don't harm bees. And, even if a bee were to ingest it, it's not going to have any effect, right? And our technology, we control the specificity by the gut disruptor that we pair it with. So that's what gives us the confidence. We've had to do numerous EPA studies for registration to prove the lack of toxicity on bees. So we feel very confident going forward that, our pipeline in general, as well as Spear, is going to be a very nice new tool for growers to use in a rotation.
Are there lessons we can pull from pharma, back to kind of the pharma example, that allowed them to make this widespread expansion of this technology possible?
Yeah, I mean, the big difference between pharma and ag is that pharma didn't already have something else that was called biologics. Right? So in pharma, biologics was just the neat new technology that had all the same efficacy as the synthetics came before, plus these better attributes, right? So the trick that we have is that in ag, the term that, should be rightfully ours has already been co-opted by some other things. And so we have to sort of educate around that. But the good news is, as Ben was saying, everybody is marching toward this idea of sort of true sustainability as opposed to, for instance, organic branding. It's an easy story to understand once it has been told to you. And so the good news for us is we only have to educate once, right? And the more we start to educate, the more we see growers talking amongst themselves, channel getting excited, et cetera, et cetera. And so, it has this sort of natural, exponential growth kind of impact once you start down that path. And because every single one of our pipeline molecules is a peptide, you only have to do this education once, right? And then that will remain the case for every peptide thereafter. And so when we introduce the second product, everybody's just going to go, oh, great, another one, right? And so on and so on.
Oh, there's so many tangents to go down here. Are there a lot of different gut disruptors available to you?
There are. We have proven over the past 3 years doing a lot of our efficacy work. We've got somewhere in the range of 300 studies across 9 different countries over the past 3 years that we're slowly beginning to commercialize into in looking at various different options. So whether it's some of the NPV viruses or BTs that are out there, there's all sorts of avenues to bioavailability that we're starting to understand. But I think as we go forward in the future, and I can let Anna talk a little bit more on this, our R&D platform is looking into what other forms of bioavailability can we make outside of just a BTK or a granulosa virus or an NPV type of virus going forward.
Yeah, so the beauty of the product as it exists today is it can be flexibly combined with any of these gut disruptors, right? And depending on what all you want to target, you can pick the gut disruptor that gives you specificity to that particular pest category. And so that's really great today. But definitely going forward, we also want to provide products that are already designed themselves to be able to generate that bioavailability and don't necessarily need a partner product. But as you point out, we want to make really sure as we're doing that we maintain the specificity that we gain from the use of something like a BT that does have that specific pest range that it addresses.
Yeah, no, and that fits a theme that we've talked about quite a bit on the show here, which is, I see in the future things being a lot less about labels and a lot more about data. And, the labels will need to be supported by data or they'll be just seen as noise and marketing. And I think we're trending in that direction, although it's not a linear path, I don't think. But yeah, obviously that plays in your favor because the data is what supports, this case, obviously. Take us back to that decision in 2017. The board decides to go, okay, we're not just going to be an R&D company anymore. We want to commercialize this. That's a heavy lift. What prompted that decision? And talk to us about how you two and your team execute on that.
Yeah, so I think what prompted the decision was really the combination of realizing that there was great potential in this company on the one hand, but on the other hand, realizing that it was probably going to be a long slog before the rest of ag really woke up to it, right? And certainly before, for instance, the majors would be ready to make an acquisition in the space. There was no choice, right, but to prove it out ourselves. And so what I inherited, right, what I took over in 2018 was, an extremely dedicated, extremely capable, but just 15-person R&D team in Kalamazoo, Michigan. And what I needed to build, right, was a company that had a commercial group, an operations group, right, all of the G&A support. And I needed to build out manufacturing relationships and distribution relationships and everything that was necessary to commercialize a product. And oh, by the way, we had to finish the regulatory process for that first product and hoped to and did eventually gain that novel nerve and muscular IRAC code for that product as well. And then, once we overcame those things, then it was all about, building the pipeline that would come behind that. And so the really exciting news from this week is that the press release will come out saying that a couple weeks ago, so middle of March, we actually submitted our second molecule basin to the EPA, and we fully expect that it will also garner its own novel nerve and muscular mode of action. Yes, and so that's part of why Ben came on 6 months after I did, is because the first thing you have to do is, build the team, and then from there, build the relationships, right? And, start creating a culture of execution around a clear vision.
It's admirable. And yeah, it does seem like, large corporate acquirers, they're not going to hop on things too early. And so they almost have to hit a wall before they want to acquire something like this. Do you get the impression that they are, developing their own peptide-based technology, or is this just kind of far off from where they're focused?
I think they would all love to, right? They're clearly all talking about their increasing emphasis on biologics. They understand that this is the future. I think, though, when you look at the way it happened in pharma, it wasn't the majors that became good at this themselves. It was the upstarts, the then upstarts, the Amgens and the Genentechs, right, that won the day, became majors in their own right. And in fact, it actually led to a complete restructuring of the industry from one that had been predominantly in-house development, R&D of those small molecules, to one that is now based predominantly on M&A and in-licensing of pipeline molecules. And what the majors are really left being good at is the late stage development and the marketing of those and the manufacturing of those molecules. So when this happened in pharma, it restructured the entire industry.
And Ben, in your experience, when and how does the light bulb turn on for the grower? How are they hearing about Vestaron, and what's being like, oh, yeah, this is what I need?
2020 was a fun year for that. We did a lot of work in terms of demonstration plots with large corporate type growers and really focused in on some of the, what I'll call more key crops where they're looking for a solution. So when you start looking at a lot of your permanent crops, your tree fruit, your tree nuts, vegetables with a lot of resistance issues, growers, they were either, buying product and putting it out in their rotation and trying to displace and just play with it a little bit, try and gain a level of comfort. But once they started to see at the end of the year that there were no differences in terms of performance, whether it was a traditional synthetic they were using or our product that displaced that in another 20-acre, 40-acre plot, the light bulb kind of went off in their heads, and just they understand that now they can start to plug us in pretty much anywhere. And now they're looking for opportune times where they're having a lot of challenges, whether it's with a higher pressure situation, whether it's, hey, I'm a large grower and I'm going to have all my harvest equipment in one spot and I can't afford to be moving stuff around. So I can make this application the same day I harvest and not have to worry about pre-harvest intervals, right? Our products bring a certain level of flexibility to them. And I think what we're seeing now is growers that tried us on maybe 500 acres last year are coming back on 5,000 acres this year. And we're working our way into those physical rotations. So specifically, when you look at the California Central Valley in tree nuts, we have a number of growers that are going to grow probably in the range of 10x with us year over year. So it's really exciting to see the adoption and the pace at which they're adopting going forward with the technology.
And going back to your question about what will make the majors sort of take notice, it's when we start eating their market share.
Yeah, that'll do it. I think that's a pretty good wall. And with that growth in tree nuts in California, what pest is that for? Is that navel orangeworm, or what pest is that for?
It is. It's for navel orangeworm specifically. For years, they've been rotating basically 2 AIs within navel orangeworm, whether it's been mummy sprays or hull split sprays. It's been pretty much a diamide or a methoxyfenazide. And now we have the capability to bring spear into that rotation, and did some great work last year that Anna alluded to earlier that gave us about 30 days control, right in line with all the majors that have been used in the past for the mummy sprays, which are coming up here in about 3 weeks. So we're really excited about the potential in that slot. But also, again, like I was saying, the flexibility allows a large grower at the end of the season, when they're trying to harvest farms that start up in the North Valley and go through the South Valley, and move that equipment along with controlling that pest population.
Very cool. Well, one thing I didn't dig into, because I just had so many options for tangents to go down, is when you talked about the food companies that are interested in this. How does that work? I know that they have a lot of influence, obviously, on their supply chain and how it's produced. But when they are working with a company like yourselves, what exactly does that look like, and how does that actually translate into, sales to the grower?
Again, it goes back to the education piece, right? A lot of times it starts at that level, but the onus is still on us to take it down to their growers and educate their growers. In a lot of cases, they don't take flexibility out of their growers to produce the crop, but they give them guidance on what they could be using, or there could be a premium if they used technology like ours as part of their agronomic practices. So I think it is that education on the upstream channel, but I think it still comes down to that grower education piece and helping them understand, here's the benefits you gain by dropping maybe a synthetic out and working a peptide into your application program.
Well, I don't know anything about pharma, but in agriculture, resistance has been a little bit like whack-a-mole, right? Where it's just like, here's the next thing until we see resistance, and we're going to go to the next thing. How do we know that this isn't just the next thing, and then we're going to, build resistance to this and have to move on to something else?
It is absolutely reasonable to expect that eventually resistance will develop to peptides, just as they have traditionally to synthetics. The thing that peptides have going for them in this case, though, or in this respect, is that because they are larger molecules with bigger, more flexible binding sites, it is less likely that a single point mutation in the insect would disrupt binding the way it easily could for a small molecule synthetic. So if you just think about bigger things with more molecular interactions between them, you have one little change on one piece, and that doesn't disrupt the whole interaction as likely as it would when you have, just a little tiny molecule having that interaction with the target receptor. And so there is not great data on this in agriculture yet, of course, because we've only just introduced the first peptide product, but there is data in pharma actually related to HIV research that shows that the larger molecules with the larger binding sites, it is more difficult to develop resistance to them. So it can happen, it will happen eventually, but it will probably happen more slowly for peptides than it does for small molecules as a general matter.
That's really cool. All right, so you're rolling out Basin, which I love the name Basin. I think that's great. It seems like, you just said we're going to go like 18 years before any of the bigs have rolled out a new mode of action. Now you're rolling out 2. So this pace of innovation just seems much, much faster. Is that something that can be sustained?
Yeah, so we right now have an R&D organization that's capable of churning out one of these peptides ready for commercialization about every 12 months. And we think that by 2025, we'll get to the point of being able to actually start commercializing 2 molecules per year.
Wow. I hope you caught what she just said there, because that makes this not only a compelling product line, but the acceleration in the pace of innovation for this industry, would clearly be a game changer as well. Thank you so much to both Anna and Ben for being on the show. Go learn more about what Vestaron is doing over on their website, which is vestaron.com. That's VESTARON.com. And special shout out to FoA community member and recent podcast guest, David Dahl, for the introductions to Anna and Ben. Much appreciated, David. Hey, thanks as well to those of you who continue to support this show, either by joining that community or by just sharing episodes on social media. It all goes a very long way, and I really do appreciate it. Don't forget also to complete that audience survey. The link is in the show notes, and subscribe to the SWAT Agronomy Podcast. We're releasing episodes over there monthly. Thanks for your time and your attention. I never take it lightly. I'll be back next week with another story of ag innovation.